Lesson 4. The standard normal distribution. It's often helpful to standardize random variables that have a normal distribution. You can code the data to do this so that it can be modeled by the standard normal distribution. Standard normal distribution has a mean of 0 and a standard deviation of 1. The standard normal variable is written as z follows the normal distribution with a mean of 0 and a standard deviation of 1. You can code the data if x follows the normal distribution with a mean mu and a standard deviation of sigma. You can code it with the formula z is equal to x minus mu over the standard deviation. The resulting z values will follow the standard normal distribution with a mean of 0 and a standard deviation of 1. For the standard normal curve, z follows the normal distribution 0, 1. The probability that z is less than a is sometimes written as phi of a. You can find it by entering mu is equal to 0 and sigma is equal to 1 on the normal cumulative distribution function on your calculator. Let's do some examples. The random variable x follows the normal distribution with a mean of 50 and a standard deviation of 4. Write in terms of phi z for some value z, the probability that x is less than 53 and the probability that x is greater than or equal to 55. Part A, we code the data using the formula we just learned. So z will be x minus mu, x in this case is 53, minus the mean, which is 50, over the standard deviation, which is 4, and this will give us 0.75. So the probability that x is less than 53 will be equal to the probability that z is less than 0.75, which is just phi of 0.75. For part B, the probability that x is greater than or equal to 55. Because the normal distribution is continuous, we can use greater than or equal to and greater than interchangeably. So we can just write this as 1 minus the probability that x is less than 55. Using the coding again, we get z is equal to 55 minus 50 over 4, which is 1.25. And so the probability that x is greater than or equal to 55 will be 1 minus the probability that z is less than 1.25, which is 1 minus phi of 1.25. You sometimes need to find z values that correspond to given probabilities. These can be found for some standard values of p in the formula booklet. It gives values of z and p such that the probability that z is greater than z is equal to p, or 1 minus phi of z is equal to p. Let's do one more example. The size of bacteria cells, S, in arbitrary units is modeled as S follows the normal distribution with a mean of 127 and a standard deviation of 16. A scientist wants to study bacteria with sizes above the 95th percentile. Find the minimum size included in their study. We know S follows the normal distribution with a mean of 127 and a standard deviation of 16. We want to find the probability that S is greater than S is equal to 0.05, as we want above the 95th percentile, so 5%. Now you can do this using the inverse normal, but for this example we're going to be standardizing it. So we want the probability that z is greater than a z value is equal to 0.05. From the table, where p is 0.05, we get z has to be 1.6449. So z is equal to 1.6449, which will be equal to s minus 127 over 16. Now solving this, we get s is equal to 153 to 3sf. And so therefore, the scientist should study bacteria with a size greater than 153 units. And that's about it.